Hello class, so today we'll be going over just a couple of problems. We're going to use the I do, we do, you do method, and we'll be going over monohybrid and dihybrid problems. So in this first one, the I do, in sheep, the allele for belly fur, which is capital A, is dominant, and the allele for no belly fur is lowercase. If you remember, our dominant allele is the one that is always shown when present, so we know that capital A means belly fur. Again, all of this can be written on your scratch sheet of paper, and you should expect anywhere from 1 to 2 questions on your STAR exam. Here, lowercase a is no belly fur. Sorry for my bad handwriting. A mother with the genotype capital A, lowercase a, so we know that this is heterozygous, and a father that is also heterozygous produce offspring. What percent chance does the offspring will have no belly fur? So again, we're looking for no belly fur. No belly fur is recessive. So remember, the only way that you can see a recessive allele is if you have homozygous recessive. STAR loves to give you heterozygous. So don't be surprised if both of your parents are heterozygous on STAR. Here, mom and dad were both heterozygous. We know that because it was given in the question. So here we have mom, and here we have dad. I'll put mom up here. I'll put dad on the side. And remember, this is monohybrid because we're just dealing with one trait, which is no belly fur. So again, you bring this letter down, and you bring this one across. Following this method, using your monohybrid, you should be able to see that this one has fur, this one has belly fur, and this one has belly fur. Only 1 out of the 4 does not have belly fur because it's lowercase a. So this means that 25%, there's a 25% chance that the offspring will not have belly fur. So again, just a quick review, you want to do number 1, which is write what your offspring is. You identify what mom and dad are. Most of the time, they'll give it to you on the question. Step 3 is your monohybrid cross. And then step 4 is just make sure you use your fraction to tell you the percentage. You do have a calculator available on the STAR. So if you just want to double check your work or you're a little bit unsure of your fractions, make sure to use it. For this next one, we do. Many farmers prefer cattle without horns because it is safer for their herds. The allele for no horns is capital N, which is dominant, for the allele for the presence of horn, which is N. So right now, on your own, make sure you do step 1. The farmer mates a male with horns to a heterozygous female. So this is the we do part together. In order for you to have horns, right, what does your allele combination have to be? So again, because it is recessive, it needs to be homozygous recessive. And how does heterozygous look like? Hetero means different, right? So hetero is capital and lowercase. What is the chance that the offspring will have horns? So again, ultimately, we're looking for offspring that do have horns, and that is going to mean that I'm looking for homozygous recessive, right? So here, we already did step 1. We identified our parents. I'm just going to rewrite the parents because I wrote in red. So my parents are right here. I'm going to start my monohybrid cross. Sorry, I'm working through it a little bit quickly and I made a mistake, which happens. Just make sure to check your work. So looking at this one, class, remember we're looking for which one is going to be with horns, which is homozygous recessive. So we have 2 out of 4. 2 out of 4, can be reduced into 1/2. and then ultimately that is 50%. So there's a 50% chance in this situation, right, that the offspring will have horns. Easy. And then lastly, for this one, they can pause the question, you can work on it on your own, and then I'll make sure to write in the answer. Again, make sure to go through the 4 different steps, and you have scratch sheet of paper to work on. In watermelon, solid green is capital G, which is dominant, and stripes is lowercase g. They cross 2 watermelon plants that are heterozygous for the ring color. So we already know what that looks like, heterozygous, for both parents. What are the odds that the offspring will have solid green rind? So our question is asking, solid green would be capital G, and heterozygous. Both of these will give us green rind. So again, work it out on your own. You set up your monohybrid and then identify how many out of the 4 will have a green rind. So we can identify that 3 out of 4, also known as 75%, will have a green rind. Easy. So these can be applied to codominance and incomplete dominance. Remember, codominance, they're co-captains. So you're going to see both of them. It's like a red flower crosses with a white flower and it makes a red and white flower. Incomplete dominance, they make a hybrid. So that hybrid is a mix. So when you mix red flowers and white flowers, it would become pink. But again, they'll give you a table and you do the same way that you work monohybrid. Lastly, class, we're going to look at dihybrid. So remember, di means 2. That's why you have, or you're working with 2 different traits. So black hair is dominant and brown hair is recessive. Short hair is dominant to long hair. So a black long-haired guinea pig, and it gives you, that one is crossed. What percentage of the offspring will be black with long hair? So again, we need to write down our traits so we do not get confused. We know that capital B is black hair. We know that lowercase b is brown. Short hair is capital H. And then long hair is lowercase h. So again, this is trait 1 and this is trait 2. So already did our first step. Our second step is identifying our parents, right? So I like to do the double monohybrid cross. That's what we're going to be doing here. So we have our first parent. And then we have our second parent. Normally when you have a dihybrid, they're pretty friendly and they'll give you the work. Again, we're splitting this into 2 different monohybrids. So again, keep the traits together. So I'm going to do B. And then from there, I'll do the H's. So again, from parent 1, they were heterozygous for the black hair. And parent 2 was homozygous recessive for brown. Again, I'm just splitting them up the way that I see it. And you're just working with monohybrids again. That's why it's very important to know that original setup, because it is going to help you so much in the long run for your more complex problems. So again, the question itself is asking how many of the offspring will be black. Anything with a dominant trait will be black. And long hair has to be lowercase l, lowercase l. Sorry, it is an H. I was completely wrong. Lowercase h, lowercase h. So looking at this one, you're going to see the traits, right? So in the first one, how many will have black hair? So black hair is a capital B. So I only have 2 out of 4. You're going to keep it in a fraction. Do not change it because you're going to multiply the fractions. Do not turn it into a percentage yet. And then long hair is lowercase h. So here I have 2 out of 4 as well. Normally here is when students think like it has to be 50%. No, you are not done. Please make sure to multiply across. Once you multiply across, you'll get your true you'll be able to get your true percentage, and it is very different. So 2 times 2 is 4, and 4 times 4 is 16. You can plug this into the calculator or you can reduce it. If you reduce it, you should be able to see that it is 1/4, and that actually equals 25%. So again, use the calculators if you need it. Just make sure to split up the trades, and it's that easy, guys. For this next one, we do in a flowering plant, tall is capital T, short is lowercase t, blue is capital B, and white is lowercase b. So again, start your steps, set it up. It gives you the both parents already, cross it. Again, the question is asking, what is the chance that the offspring will be short? So we know that short would be lowercase t, and then that you have white flowers. White flowers is lowercase b. So then try to work it out, and then you can pause the video. You'll be able to see the answer coming up. So again, I'm doing my first step, which is to write my traits. Again, because I am comparing 2 different traits, which is the height and the color, I know this is going to be dihybrid. Next step, I'm just simply writing the parents. So I'm making that cross very quickly. Please remember to split them up. So I'm doing dihybrid cross, but I like to split them up by the same trait. That's the way that you should be writing this. So again, I'm going with height first, and then I'll go with color. Again, I'm looking for short and white. Those are the traits. So out of my first monohybrid, how many are short? Remember, short is homozygous recessive, so they have to have little t. Here you should identify that 2 out of 4. Remember, do not do anything with the fractions because you will multiply them. Okay, for this next one, again, we're looking for white flowers, which is depicted by homozygous recessive or little b, so I know it's 2 out of 4. Again, multiply across. So 2 times 2 is 4. 4 times 4 is 16. You can reduce it to 1/4, or just plug it into the calculator that is provided, and we know it is 25%. So with these parents, there's a 25% chance that the offspring will be short plants with white flowers. This last one you are going to do on your own. You can just check back to double check the answer. But again, please make sure to go through each step and write everything out on your scratch sheet. So in rabbits, the dominant trait is white fur and black fur is recessive. Long ears is capital or dominant. Short ears is recessive. So we know the dominant is white, the recessive is black. We have long ears, and then we have short ears. The breeder makes 2 rabbits that are heterozygous, so it tells us our parents right off of the bat. So both of our parents are heterozygous. Remember, Star loves crossing heterozygous parents, so don't be surprised if you see this only because it gives you a lot more different options. What is the chance that the offspring will be black with long ears? So again, these are our dominant traits. As long as you have a capital B or a capital E, you will see black or long ears. So again, we're going into our third step. We're going to write in. So here we have our first trait, and here we have our second trait. Just going to make our monohybrid boxes really quickly. So again, one trait and then the other. Keep the same letters together. So here I have the color. I like to be very dramatic in the size. This one was supposed to be actually a small W. Oh no, I am correct. This one, oh no, let me rewrite it. I'm gonna try my best. The E works really well, the W does not. You wanna make sure that you draw the different sizes to avoid confusion. So that's definitely a big W, that's a little one. Here I have another big W, and here's a little one. I wanna make sure that you're able to clearly see the difference. Okay, so again, we want to see how many have black fur with long ears. I was actually incorrect. So black fur is little w, and then the long ears was correct. So here, out of how many of the four actually have little w or homozygous recessive, it is only one. So we have 1/4. The next one, we just set it up very quickly. These letters are a lot easier to work with because the capital and the lowercase look completely different. I like these types of letters. Okay, so how many of the offspring will have long ears? So long ears is dominant to short ears. So as long as it has a capital E, we have 1, 2, 3 out of 4. So we're going to multiply this. 3 times 1 is 3. 4 times 4 is 16. So 3 out of 16 would be black with long ears. And that's it. Most of the time the question will be in multiple choice, or if you do have to write a percentage, it'll be a lot easier. Hope you'll have a great day. Bye, guys.